Hi, everyone. This week we're going to talk about Chapter 6, which covers the best ways to visualize parts of a whole. Data on parts of a whole is going to be prevalent anytime you're reporting human subjects data, and that's data that you've collected from people. And one of the reasons that it's so critical to report parts of a whole when you've gathered information directly from people is to make sure that the sample that you've gathered the data from is representative of the population that you're trying to study. Data about people is not very useful if the people that you're interested in studying are not the ones who are getting a voice in your data. Now, as a quick reminder, earlier this semester, we talked about pie charts as a part of a whole, and pie charts are great if you're only going to represent two parts of a whole. Because people have a hard time distinguishing the difference between the same types of angles, if you have more than two groups, a pie chart isn't the right choice for you. Something that might be a better fit is a stacked bar chart. In a stacked bar chart, you represent 100% of your data, and you color code groups according to how much of that 100% is represented by each group. Now, stacked bar charts are something that is a bit of a pain to build in Excel, but you'll find that it's very easy to do in Tableau later this semester. A word of caution about stacked bar charts, though. We begin to struggle to visualize the difference in group sizes when there are more than 4 groups in this type of visualization. So if you have more than 4 groups, don't use a stacked bar chart. Take a look at the example I've given you. We have 5 groups represented here. Are you 100% confident which wedge is the biggest? Unless you have superhuman vision, this is probably hard for you to determine. And that's why it's really important that you don't use a stacked bar chart when you have 5 or more groups. A histogram is another great option for representing parts of a whole, but a histogram specializes in showing the distribution of scores. Now, this may be scores on a test, results from a questionnaire, results from an aptitude test, or it can even be something such as breaking down household income or student loan debt represented in a sample. Histograms take continuous data and they plot them in such a way that you can see how the scores are distributed throughout a sample. Here we see a histogram with quiz scores. Assumably, the scores in this quiz only range from 0 to 5, and it looks like most students scored between 4.5 and 5. Histograms are something that you've likely built several times before and can easily be constructed in Microsoft Excel. Here's that quiz score data. In order to build the histogram, I need to select the data, go to Insert, Histogram, and here we go. Now you'll notice that these bins are rather large. They go from 1 to 2.3, 2.3 to 3.6, and so forth, all the way up to 6.2. But our scores here only range from not even 0, 1 to 5. So these bin sizes, the width of these bars don't make a lot of sense. If I want to edit this, I need to click on the plus sign, go to Axes, and More Axis Options. Here, we're automatically taken to the bar menu, where I can choose a bin width and set it to 0.5, which makes sense because that's the largest difference I see between the scores. If I hit enter, my chart updates. Here are my students that scored between 1 and all the way up to 1.5, and so on and so forth. This is much more representative. I can make other edits here, such as changing the title by double-clicking. I can also click on the bins themselves and change the color if I wish. Excel is designed to make histograms quick and easy. Now, another type of visualization that Excel is not great at is a tree map. Do you remember this visualization from your David McCandless TED Talk? This is what he called his billion-dollar-gram. He represented financial chunks of a whole with proportionally sized boxes, and then he color-coded them according to the motivation behind the spending. This is a tree map. It's a way of representing continuous data with proportionally sized boxes. I do not suggest trying this in Excel. Again, wait for Tableau. The last option for representing parts of a whole is maps. Excel does this well as long as you have a pivot chart representing a summarization such that you have one data point for each geographic location. If you have more than one data point, such that your data is not aggregated, a program like R or Excel is going to be much faster at creating a map. But maps are wonderful for showing how data is distributed across geographic locations. We're going to practice this later in the semester in Tableau. If you have questions about the type of data for telling how data is distributed among groups, be sure to let me know.